Hey everyone, welcome back to the shop. I'm Rob, and in this video I'm going to stop talking and start machining. We're going to turn a aluminum cube like this into the laser head like this. And there's a lot of steps, so let's just get straight into it. So first step is to square up the stock. Aluminum extrusion is never even really remotely square. The bandsaw cuts from the supplier were actually pretty good, but to get any kind of accuracy in the machining, all 6 sides have to be square and perpendicular to each other, really. I'm not going to go over stock squaring. Many other YouTube channels have videos on it. Just note that the drill bit under there is operating as the pivot pin because it's reasonably precise in diameter along its length. Once you've got the first couple sides square to each other, then you can just square it all to the vise. I'm using a 1, 2, 3 block here. You could use a machinist square or whatever, it doesn't really matter. And yes, I am still using a dovetail cutter as a face mill. I'll rectify that eventually. I'm floating it off the surface of the vise here slightly, because the bandsaw mark wasn't really cooperating with the 1, 2, 3 block. So I just removed it from that surface entirely and allowed it to be perfectly perpendicular to the ground surfaces. Once it's finished up and all the bevels are filed out, it looks a little something like this. I wanted to mill the large chamfers in the front first, because that was going to be the most milling force on any part of the build. And I wanted to do that before I milled all the features in and made work holding a lot more difficult. This is indicating in the side that was going to be fixed and provide the exact angle every time. All the clamps were going to operate against this surface. End mills are usually upcutting. They want to dig into the pod and lift it out, so you've got to throw a strap clamp on there to keep it down. I love the aggression of roughing end mills. I got something like 1/2 inch step over, that's full diameter on this cutter, with 3/8, maybe a 1/2 inch depth of cut. It just chewed right through it. And that's even on a mini mill like this with lower rigidity. Since these aren't critical surfaces, I'm really not too fussed about the surface finish. Technically any increased surface area from flaws left by the cutter are all to the good of the heat sinking effects of the unit. So here's a technique I'm not going to miss. So, in order to zero on the corner of any piece, especially a piece like this that doesn't have a corner, there's no real useful way of maintaining a zero on a stock mill. The collars on the hand wheels are supposed to be zeroable, but in practice that doesn't really work all that well, mainly due to the backlash and stuff in the system. So, what you end up having to do is catch one side, come in a certain prescribed distance to be able to catch the second side, and then once you do zero on the second side, you have to then go back out that same prescribed distance in order to be on the 0 point that you can then measure from. It's super tedious and time consuming, and a DRO is going to fix it completely. But that is something for the next video. Putting sanity lines on stuff, as you see here, is generally a very good idea. I'd forgotten to take off the 100,000ths in each axis. That is the radius of the edge finder. Obviously that has to be taken off first before you're genuinely on edge. Putting the witness marks in the diagram keeps me on track. Even if I'm not thinking, 2.5mm off center is enough to point out that there's a problem. I prefer using this stub drill for center drilling, because I think it's higher quality than the center drills I have, to be honest. Here I'm center drilling just to get the 60 degrees to sit this on the lathe, using the tailstock, and this is just some relief and flat sidewalls so that I can indicate it in on the lathe. A lot of machining is done by feel. You can feel really tiny movements and edges with your fingers. So here I'm just applying pressure with the tailstock and allowing the jaws just to naturally come in and sit on the sides of the workpiece without actually pushing it, and it's that sort of tipping over from that pressure that I'm feeling for. The tail stock probably puts it within about 5 thou of center, so dialing it in exactly with a TDI is pretty easy. I need to know exactly how tall I've left the rough finished piece, so I know how much I have to split between facing the front and back of the workpiece, or the top and bottom in this case. I've been having some finish issues on the last few projects with facing specifically. Chatter from vibration of the tool post. I think I'm going to have to make a solid tool post holder. I know it's fashionable on YouTube right now, but it seems like I'm going to have to do it anyway. Then it's just a case of turning the shoulder that defines the base outline and is the outer wall for the pressurized interior. First center drill is 3mm to do the laser power leads. Going through a full 2-inch block with such a narrow drill is a little tricky, but I got there in the end. As you get closer to the end, you have to start backing it out a lot more frequently because the chips gum up the flutes really quickly. Then just a quick clearance hole to take me through the rest of the steps on this front face. First thing to do is bore the relief for the lens housing. This provides enough airspace around the knurled outside of the lens for air to still smoothly flow from the inlet down through the nozzle. I was trying to maximize the amount of air volume inside of here without sacrificing too much actual solid metal heat sinking capability. Now, to continue boring out the volume of the interior, I actually need to have a face grooving ability. Obviously, I don't have several $100 Sandvik insert systems, so good old-fashioned HSS and friable aluminum oxide grinding wheel is the way to go. Friable means that the bonds, the vitrification bonds between the particles of the wheel are less plastic, I suppose, than traditional wheels, which means that they're more prone to sort of flaking and breaking away from each other, always exposing fresh, new, sharp surfaces as you're grinding. They're also easier to dress. It actually worked way better than I thought it was going to. Between that chatter problem I was having and the relative stick out of the 1/8 inch HSS blank, I wasn't actually expecting it to perform as well as it did, but it went really smoothly. Since the inside is really just clearance for whatever size the air intake is, I could afford to be approximate and just go to a scribe line. Really loved the way this cleaned up in the end. So for the laser housing hole, I actually couldn't use the original face grooving tool I made. I actually had to grind another essentially boring bar from, I think it was 1/4 inch stock HSS blank. Used a nice piece of, I think it was Cleveland Momax Cobalt. Good quality stuff. I got it in a bulk lot from eBay one time. Basically, it was fairly similar to the first one, except there was a lot more clearance at the side and underneath, especially along the length of the shank, since it had to go in quite a long way. Onto the top. I still don't know if I'm actually going to use this counter bore or not, but I wanted to put it in just in case. I might need the extra space to seal around the wires for the pressurized interior, And I wanted to have a indicating surface just in case. And a nice skim pass to really finish off the top just right. Alright, this side is actually the back. The chuck is holding the top and bottom and the two sides of the cube. This is the chamber that I alluded to in the last video, which I wanted to be a sort of pressure vessel. Whether that's positive or negative pressure, I'm not entirely sure yet. Depends which way round I put the fan. I don't think either way will work particularly any better or worse than the other. I'll probably do a A/B test anyway, with the fan front facing and rear facing, and see if it makes a difference to the core temperatures or even the external temperatures of the head itself at any given power level. And back to the mill. You can see the scribe lines I'm putting here. I just added the drill marks inset from those lines to do the radius corners. This is to slightly inset that Noctua cooling fan into the back of the enclosure, just so it has a really sort of positive seat. I don't know if that's necessarily going to make a difference to the sort of sealing of the airflow, but I think it should, at least a little bit, and maybe I could also add a little bit of silicone gasket or something just to be on the safe side. I don't know if going overboard on the fan like this would really make a huge difference, especially if I'm doing a pressurized airflow from a compressor directly through the laser enclosure and down the nozzle, but I'm trying to cover all my bases here. I figure if something ends up being unnecessary, then I can simply not use it and it's not really a big deal. But I'd rather not have to come back in and try and remachine elements to sort of fix problems that should have been foreseen ahead of time. Here I'm just milling to those scribe lines that I put, but for these holes that I'm about to put in here that pass the actual laser body and therefore intersect with the laser bore itself, I'm trying to hold to a fairly reasonable degree of precision because that intersection was part of the original design. So getting the exact distances between each side and the center is reasonably important. For these top holes, of course, where the actual motion control elements mate with the head, it's pretty critical on the placement because it actually has to interface with the rest of the machine. More 3mm through holes, just as tricky as the one down the center on the lathe. Fortunately, these are just bolt holes. It's just a 3-bolt pattern. I drilled it from the bottom because that's a far more critical placement in terms of where the bolts actually sit, because that's where it interfaces with the air boot, as I call it, whereas where they actually come out the top probably doesn't really matter that much. Obviously, this being the last hole to drill, I had to do something really stupid. Okay, a little quick breather here to catch up on the state of progress. This is basically done, all the features are in, all the tolerances are there. Almost everything is actually exactly as modeled in Fusion 360 in the last video. Pretty happy with that. Everything fits nicely, no slop, no wiggle, no nothing. So I'm super happy with the way it came out, except for the dings I put in it on the last operation because I was an idiot. But I'm gonna take a fairly hefty chunk out of these edges anyway when I bevel them over, and it didn't take any damage on the important bit, which is this sealing face right here where the air boot is going to go on there for the compressed air. So it's all good. I'm going to mat all of these surfaces up, give them like a blasted finish, just by lapping them with coarse sandpaper, basically, emery cloth, whatever. This surface I may bring up to a higher finish. I might take it up to maybe 6,000 or so grit, whatever I have on hand, 3,000, whatever it happens to be. Give it a nice polish so that it really mates with its mating surface nicely. Because I don't think I can really put a grease in there. Probably. I mean, there might be a high temperature pneumatic grease that I could put in, but that just seems unnecessary. I just don't want whatever's doing the sealing to be able to evaporate away once this thing heats up, basically. So I'd rather just have surface to surface. But yeah, once I've blasted all of these surfaces, then I'll cut the fins in, and this will be done. Then all I have to do is the 8mm rods and screw. I didn't drill these holes at 8mm, I drilled them with a 6.9mm stub drill, just to get more accuracy and squareness, and I didn't want to sort of bring it out to 8mm just in case it moved around too much. So I'm going to take the other stuff down to 6.9mm so it fits exactly in these. And that's it. We'll get these surfaces finished out. We'll get the mating motion control components added in, and we'll be good to go. First step is obviously to try and clean up those rough milling marks. Should probably, in retrospect, have actually just gone over them with a finishing mill. But I didn't think it would be quite as much to clean up by hand as it turned out to be. Wasn't too big a deal though, just a little time consuming. Then it was just a case of grinding out all of the faces, getting everything to a reasonable finish to take paint, and then beveling the edges, which were kind of handy to use for the initial pass of sanding, because it gave me something a little more positive to grip by. Onto the smoother grits, where it wasn't trying to tear the piece out of my hand. Main thing here was to try and use reasonably good lapping technique, obviously keeping it rotating and trying to keep the pressure even across the whole surface. Make sure everything was averaging out nicely. Final operation. Since I didn't feel like stopping the project to turn a slitting saw arbor, I had to go with an end mill. Turned out my smallest end mill was still 3.5mm, or just over 1/8 of an inch. So the slots are a little bigger than I'd like, but it should still turn out okay. I don't think they're going to be doing very much of the actual cooling at all. I think I was only cutting at a depth of about 50 thou, or about 1.25mm, something like that, somewhere around there. The 4-flute end mill was experiencing quite a lot of deflection, so that's the reason I'm going back and forth a lot. Try and clean up the surface finish and get the slots nice and straight. Of course, despite my best efforts trying to keep the path clear of chips, avoiding recutting and minimizing the forces on the cutter, the inevitable still happened. Since I wasn't convinced with all the air movement happening inside that the cooling fins would actually be doing a whole lot, I decided just to leave it there as a sort of design feature, since it looked kind of cool and asymmetrical, and just get straight on with the paint prep. That basically just consisted of wiping down every little nook and cranny that I could get to with barbecue lighter fluid. It's naphtha, I think. I think it's just naphtha. And that did the job really well, degreasing and cleaning the surface. Still used that self-etching primer anyway, Really did a good job filling in any imperfections left in the surface from the cutters or the filing or whatever. I actually really liked that grey finish, looked like an untextured 3D object. But I continued with the thermal finish anyway, matte black for maximum radiation. And that was it. Okay, congratulations if you made it this far. It was a little longer than anticipated, but this thing was a little more complex to build than I'd originally envisioned. I'm super happy with the way it came out though. I think it's a perfect start to the build. The rest of the build will be over the next 3 videos as intended, I believe. Still on track for that, as I was saying in the last video. If you want to see those, if you like this, then I guess subscribe for that, and otherwise, thanks for watching.